We normally try to keep you informed of interesting upcoming events going around the Bay. On September 26th, Vertica Big Data Meetup, the old HP Enterprise offices in Sunnyvale, to discuss their new version of Vertica, machine learning, Project Nimbus, Vertica in the cloud, and more. They also claim they will have grub from DishDash, so that's a good reason to go in itself. RSVP info is on the Vertica Big Data Meetup page, so meetup.com. October 4th, the Google Developer Group Silicon Valley is having a talk focused on Google's Smart Home API. They will discuss the Google ecosystem, how Google thinks they'll be interacting with homes, and discuss the home APIs and build a sample app. Again, more information is at the Google Developer Group Silicon Valley Meetup page. DevFest is a community-run event over the course of the next, of course, 3 weekends, not the next month. There will be a code lab up in Berkeley on October 21st, some tech talks in San Francisco on October 28th, and a hackathon with prizes in Fremont on November 4th. That you have to sign up and buy tickets for at bayfest2017.com. On October 24th to 26th, the ScyllaDB Summit will take place in San Francisco, and will gather Scylla and Apache Cassandra community members, users, and developers for 2 days of talks, demos, and workshops. Speakers from Twitter, IBM, Baidu, CERN, Intel, and Proofpoint, as well as Scylla's own experts, will offer a range of talks on use cases, field reports, how-to, and operational procedures. You can use the code BAYMeetup to get a 24% discount, and we're going to be raffling off 2 tickets at the end of the show. You had to have been RSVP'd to the meeting, and you have to be here to win. Finally, on October 26th, Advantech is having their Advantech Solutions Day in their Milpitas office. This is a free all-day event with speakers from Intel, Micron, NVIDIA, Datacore, and Advantech talking about some of their latest server and storage solutions, a tour of their showroom, and an opportunity for some hands-on interaction with their products. I'm also told they will have some authentic Taiwanese dishes and some other interesting things to eat, and we'll be raffling off some prizes like airfare to they don't say where, DJI Spark or a GoPro, so fun stuff to go there, and it's free. Full details are at their URL. I have all the URLs and QR codes over there for you to scan if you are interested in any of those. Okay, before we start, we please ask you to check your cell phones and turn them to vibrate or stun. We all know we're on call and we get paged. We won't look badly on you, but if you do get paged, please try to minimize the disruption and take a step outside. Tonight we have a really great pair of speakers from Rancher Lab. They will be talking to us about leveraging one's Docker experience to help take advantage of Kubernetes, an open source system for automating and managing containers across a fleet of servers. These are powerful and still relatively young tools that have helped to change how many organizations manage their operations. If you haven't at least played with containers yet, you really should get into that. So fresh from the ranch, we please welcome Alina Prokarchik and William Jimenez.
Okay, good afternoon, everyone. How are you doing? Good, okay. I think it's really cool how you guys do the virtual job board. That's always a great opportunity. The CEO of my company is here tonight, so we might have another opening if I don't do well. So keep you guys informed on that. So we're going to talk tonight about Kubernetes for Docker users. So how many of you have used Kubernetes before? Cool. How many of you guys have used Docker? Not bad. And then how many of you have used computers before? Well, that's ironic, the number went smaller. But so just a little bit about us. I'm William, and you can read my bio faster than I can tell it to you. Want to say?
I'm Alina. I'm a software engineer at Rancher Labs.
Very good. So we're gonna be your host tonight. So let's go ahead and dive in. So I want to tell you kind of a bit of history about where we came from at Rancher Labs. So when we're talking about Kubernetes, you kind of have some context. So as you guys know about Docker, since you guys mainly raised your hands, it was a wildly popular tool when it came on the scene, right? They really nailed the user experience for the developer. They figured out how to do that really well. Everyone kind of jumped onto it. It was initially focused on the developer user experience on a single host, right? So it's really designed for a single computer, a single Linux box. It deals with the namespace and kernel context of a single server, right? Which was still great. But then there's this gap, which is how do we operationalize it? So how do we make it work for all the guys in the room here who have usually more than one computer, right? Unless you shouldn't be at the large installation meetup if you don't have more than one, I would assume. So you got all these computers, you got all these Docker runtimes, all these kernels that are doing all this magic with isolation of processes. And so how do we manage those things as one? And so that's where Rancher came in. We saw this gap, and so we sought to help solve those problems. This is Doge, by the way, in case you don't know. You can say hi, or not, that's fine. You know, it was taking all of this ingenuity and experience that Google had developing containers at scale for 10 plus years, right? They had something called Borg, which actually was called 7 before I found out, which is kind of interesting, based on 7 of 9. Any Star Trek fans here? I'm not necessarily a great Star Trek fan. I like it, but I don't know enough about it to claim to be one. So it was like the friendlier Borg was 7, and then they eventually called it Borg. I don't know why. And so, you know, Kubernetes was really based on that. Mesos as well, actually. Mesos was inspired a lot by Kubernetes. And Kubernetes became super popular. We immediately added support for it in Rancher's product, and so we orchestrate Kubernetes. But even still, what was interesting was a lot of our customers preferred the native Rancher experience. So they didn't use Kubernetes even though they could have chosen that in our product. They still chose the Rancher experience. So why is that? Well, I'm going to make the claim that Kubernetes can be hard. It's very powerful, but it can be hard. And here's why. Google solves problems for a unique scale. So just a snapshot, just to kind of paint a picture of what we're looking at. According to their 10K last year, they had 27,169 employees in R&D alone. How many of you guys work at a company with that many engineers? You work at Google. Oh, IBM? Do they really have that many? I'm glad I didn't use them as a comparison point. That would have blown my slides. So the Google code base has 2 billion lines of code, over 1 billion files comprising 86 terabytes of code. Can you imagine the git checkout on that one? Yeah. Go home and come back later. Come back in a week. I think they actually have written their own source control tool. And I know Facebook had to go to Mercurial, I believe, because they couldn't get Git to scale with Facebook size, actually, which is not as big, but also, so Git is not designed necessarily for massive sizes like this. They're more about the submodules or very modularized Git usage. And I'm digressing, I'm sorry. The point is, though, Google has really unique scale, right? 75,000 commits a week. So this is a really, as far as environments where things can be grown, they will incubate very unique organisms in engineering, complexity and power, because they have very unique needs. In order to meet these needs, you have to develop something very unique. And just to compare what we're talking about with other companies, some of the other big internet properties, Facebook, you'd agree, is one of the bigger internet properties. LinkedIn, when you think about companies that do massive scale, LinkedIn's got massive database technologies they've developed. They're not even close, right? 72,000 total employees at Google. Facebook had 17,000 the same year, LinkedIn 9,000. So just an idea kind of what we're talking about, that Google's in a world of their own. And so Kubernetes, again, was designed to solve the challenges of the largest internet property in the world, which is really cool. And it's really exciting for all of us to be able to take part in it, but that can sometimes mean it's hard to work with. It's unrivaled in power and features, but it can be challenging if you don't have the expertise or the experience with it in-house. So that's kind of the problem set that we saw then with Kubernetes. Again, similar to Docker, it was this amazing premise, but it had a bit of a gap. And so Rancher then sought to help bridge the gap for the end user. So we asked ourselves this question: what if we could make Kubernetes as easy to operate as Docker? How cool would that be? Yeah, not very cool, apparently. There you go. Yeah, thanks. It is. Such a thing is possible. Or it could be aliens, I don't know. And there it is right there. So that is Rancher running Kubernetes. So something about Kubernetes that's interesting is it's a microservice. So if you were playing Buzzword Bingo, you can check one off there, microservice. And microservices are something that are very, very within our nature at Rancher to manage, because we deal with lots of small containers. We deal with this sort of philosophy of modularization as a first-class citizen, and let's have lots of moving parts. Let's embrace that complexity. That's something that we do well with, and so we can help with those type of problems. So we're like, we can help deploy Kubernetes. So what do we do? Well, we do all sorts of cool things. We manage Kubernetes services. We do network management. How many guys have tried to implement Flannel or Calico here, or Weave? Yeah. There's only a few brave people who've even tried doing it. So this is something we'll do for you automatically. Those are great technologies, by the way, but not everybody has the time to become an expert at those things. So we'll handle that for you. We'll manage Ingress, deploying pods that need to be highly available, so you have many behind some sort of Ingress resource. Very easy. And we do that in a way that's agnostic to the IaaS underneath it. So if you're using EC2 or VMware, you can use the exact same YAML Kubernetes resources to describe it, because we'll run the same managed Ingress. The Kubernetes dashboard, Heapster for analytics, Tiller for Helm charts. If you guys have used Helm, you know that Tiller is the server-side component you need. We'll handle that all for you. So it's kind of some interesting things, I think. So does that make sense overall, the problem set that we saw with Kubernetes, that it's really powerful, but it's not easy? Has anyone found it to be easy to use? Let's ask that question. Okay. There's always one guy who says, you guys are all nuts. It's really easy. It's getting easier. It really is. I mean, I really appreciate the open source community on Kubernetes compared to other projects I've seen. They've really set the standard. Even just the special interest groups, like the level of discipline and leadership in those things, just to kind of keep everybody moving in an open source world where no one's getting paid to do this. It's really impressive. So I just have a ton of respect for what they're doing. So how does it all work? Well, that's why we have our smart person here. So Elaine is gonna take over from me and save you guys from the rest of this and give you something more interesting and talk about really what's going on under the hood and all the core technologies.
I only have to figure out how to hold the mic and operate the keyboard.
Oh, we didn't think of that, did we?
All right, so there are a few key areas that we wanted to address. First is the installation of the Kubernetes, then managing the upgrades, because Kubernetes is a fast-growing product. It releases every 4 months or so. We also wanted to monitor the health check of the Kubernetes components and ECD disaster recovery. And we wanted to provide a Kubernetes key services like the dashboard, Helm, and kube control. And RBAC, of course, access control. So 3 steps to deploy Kubernetes. If I'm a Docker user and I have a Docker host, all I have to do is to run Rancher with one command, and then create a Kubernetes environment, and that's I'm going to show as a live demo.
You didn't know I was going to put that in.
Okay. By some reason, I couldn't access the GC. Okay, here we go. So this is the Rancher installation that I created with just one step. So the first thing that I want to do, I want to create an environment. I give it a name.
Actually, yeah. R&D spent a week or 2 on that, right?
Here actually we give user choices of what orchestration tool to choose. And Kubernetes is the most popular one, of course. So then I just click on create. And I switch to this environment. Soon me. couple of refreshes. So it says setting up Kubernetes, and the first requirement is we have to add at least one host. Then we go to the infrastructure host page, add host. And here we give user a choice. We can provision the host. We can either on DigitalOcean or Packet or Amazon EC2, or you can run this command on any Linux box, and it will just connect that host to Rancher server. It might take a while, so I'll just switch to the existing environment where my Kubernetes cluster is already deployed. Yeah, this is a Kubernetes. And here's the... Yep. Oh, the hours, no, just less than a minute, but I'm impatient, so. The Kubernetes system stack, and those are all the services that help to run Kubernetes and that we deploy in a container as a containerized application. So you can see all the services on this graph. Hope it's big enough. So this one is the etcd, the key value store, the Kubernetes database that gets launched first. And this is a Kubernetes API server that talks to the etcd database. And those are all the rest of the services that talk to the Kubernetes API server, like controller, scheduler, kubelets. You can also view the contents of the deployment by clicking the view config. So we deployed using the Docker Compose file format. So all the Kubernetes services with all the parameters are described here. You can customize it. We give some options. Then, as I said, we monitor. Again, you can see that it says unhealthy, so we are bringing it back, and then it should come up as green in a few seconds. Click refresh. Yeah, it is green. All right. Yeah. In addition to creating the key Kubernetes services, we also create a Kubernetes dashboard, DNS, and kube control. And here in the UI, you can actually choose Kubernetes dashboard for launching your Kubernetes apps. Or if you're a CLI person, you can go to the Kubernetes CLI, and you can run the kube control either from the UI, or you can just generate the config, copy it to your local machine, and connect to the Kubernetes cluster. So now we deployed our Kubernetes system stack, and it is time to deploy the Kubernetes application. But first, we want to go through the Kubernetes basics. As a Docker user, I know Docker containers, and Kubernetes has its own terminology. All right. Pods. So what are the Kubernetes pods? That's the smallest unit that you deploy in the Kubernetes. And it's usually one or more containers that are scheduled together on the same host, and they share the same networking space and the IP address, and they can speak to each other via localhost. For the rest of the presentation, let's just think of the pods as containers. Then the deployment, think of it as a management unit for the pods. So you can manage the scale of how many pods you're going to start. You can do the upgrades and rollbacks for your pods when the new image is released. And usually people, they use the deployments instead of running the pods directly because it's more because it provides all the functionality that we just talked about. Then let's say you have your application running, and you have to give an access to the application. That's where the service comes. So it helps you to define the DNS entry that allows you to access your application. And it's consistent, it never changes. The pods behind it can change, but the service IP doesn't do it. And it's similar to functionality of the load balancer. Like once you hit the service IP address, it gets redirected to one of the pods in the random order. Config maps is like a key value store in Kubernetes. It allows you to store any arbitrary data. I don't recall it's configurable. And then Ingress. Ingress actually defines how traffic flows from outside the cluster to the cluster. It exposes Kubernetes services to the world, and it also allows you to define the hostname routing for your services. Let's say if you want to access abc.com, it can redirect you to the set of pods that are meant to serve that abc.com. Now, William is going to live demo of deploying the application in Rancher.
All right, more live demos. This is always risky, but let's actually do it through here. So I'm going to show you guys in the CLI how to deploy an application using Helm. How many of you guys have used Helm before? Okay, how many of you guys have heard of Helm? Okay, that's better. Yeah, so Helm is a technology that allows you to package the definitions for Kubernetes resources. They're usually in YAML. Lets you package them all in a single object that's versioned and has certain transactional characteristics that are very handy. So you can think of it as like a recipe, kind of like other technologies like Chef maybe or Puppet, where you could just have this module or recipe that was the unit that contained everything, and you just say do it. Or even maybe Terraform's another good example. Okay, so what we're going to do is you had it easy because you didn't have to hold your. Can you hold it from? Yeah, I actually have to do. So I'm gonna borrow from here real quick because this is where I was just grabbing my commands from. So we're going to install a chart right now for something called Istio. Istio. There we go. Okay, my Greek is a little rusty. Istio is a technology for managing microservices and providing connectivity between them. It's really cool. Not the point of today's talk, but happened to be something I was blogging about recently and was developing an example of some Helm charts. So it's a good way to show you, and it has a lot of stuff in it, so it's a good example. So first I have to add the repo, actually. I'm realizing that my Helm environment didn't carry over from when I just tested this, so I got to do it again. Okay, actually nothing's there, so I'm showing you a lot about Helm. So first you have to initialize Helm if it's a brand new environment, create some local files. Helm is a client that works with something called Tiller, which is the server-side manager that actually then talks to the Kubernetes API. So Helm is just kind of like a surrogate to another broker which talks to Kubernetes to tell it to deploy stuff. So now I've got Helm. Now I can add the repo. Add it to your repositories. Can you guys see that okay? Yeah, okay. And now I can say install the chart. And so the chart here is pointing to that repository. This is from the Kubernetes incubator. Seem to have, well, let's just name it something different. Okay, so now we're deploying this chart. And in this case, it's going to deploy the namespace Istio. Istio? Istio? Accent on the I, okay. Yeah. All right, so now it deployed it. And now let's go take a look on the dashboard. Let's take a look at what we just deployed. Have you guys seen the dashboard before? Yeah? Okay, so it's going to be in a different namespace, so we'll have to, if this works. The connection's a little.
The Rancher is slow, but because I'm going over my phone.
We might be in like a Faraday cage or something. Which service do you have? Okay, so let me just show you with there we go. So there is Istio. There's the services we deployed. And you can see there's the old one still, unfortunately. But when we look at pods, we'll only see the running one because I did terminate the pods. little slow. Slow. In the meantime, I just want to show you too, though. I just want to show you what this looks like in terms of Helm charts. So the charts are just YAML files with some slightly different settings. Some slightly different settings that allows Tiller and Helm to interleave different content. So it actually has a templating engine, so you can pre-render things dynamically. So, but they're very, very similar. So essentially, we had all of our application described in this Tiller or this Helm chart, which you can think of just as a config file, declarative, not imperative. And then we just simply say Helm deploy, and it deploys it. It's being really slow. I'm thinking we're having some network issues, but we'll come back to that. So.
Yeah, as we, it's all right. I've heard Kubernetes 1.8 got released, the alpha version, and my version of Kubernetes is 1.7.4, and I would definitely like to upgrade. So, and I see the upgrade available button, and when I click on it, nothing happens. Really slow. Just turn it off.
So this is a Google cell phone network, so Kubernetes should run better on it, right?
This is iPhone, AT&T.
Oh, it's an iPhone. Yeah. Well, obviously.
All
Sorry,
right.
Apple.
Oh.
These are warm up. It seems to block GCE. I don't know.
I can actually. I can actually add a Kubernetes to this setup as well. I can add it from the catalog. The catalog is where we host all the templates in a Docker format in Rancher. So I'm going to search for Kubernetes. So here you go.
So while she's doing this, when I showed you earlier that I could install a Helm chart, which is basically a configuration of a bunch of containers, imagine if you could do that same thing just through clicking on this button in the UI. That's kind of what our catalog is about. And you'll see in the future we're going to integrate that into Kubernetes technology. So you'll be able to just click a button and deploy a template with all of your services and containers.
I'm choosing 1.7 version so I can demo the upgrade. We launch Kubernetes services in order. First we launch the etcd, then the Kubernetes API server. Because the images are being loaded to the host. The services are becoming green. So first the etcd. Oh, we are saving everything. Everything is saved. The content is saved. The downtime is pretty minimal. Yeah. once the new version of Kubernetes is released, we immediately upload it to our Rancher catalog, so it becomes available. So here we can see all the upgrade options for this particular system, and one of them is Kubernetes 1.8 beta. So all we need to do is just choose it and customize it to your needs, and just click upgrade. And as we said, all the user content is going to be preserved. The services, the pods, all we upgrade is the Kubernetes system stack components.
Cool. Question? Yeah. This page. Oh, the fields you can fill in, yeah. So there's sane defaults, right? So that should be optimal in a lot of cases. You can definitely, refer to our forums or get on our user Slack to get advice on that. I mean, that stuff is a little more complex than we could just tell you right now. And of course, at the risk of making a plug for our support and our commercial services, that's also what we provide our customers who need that sort of guidance. But yeah, there's also a lot of good documentation online because some of these things are very generic, etcd behaviors or
scale for DNS, SkyDNS service, or if you operate in an air-gap setup and you want to customize your repository for the images, we allow you to do that.
Cool. So I find 42 is a good answer for a lot of them. That always works for some reason. Yeah, it works. It always works. Okay, so we've shown you kind of this timeline of how things have evolved, right? So we started with the Rancher experience, and then we started to add some of that to Kubernetes. And so I wanted to just take a moment to talk to you about some of the things we've been thinking about in the meantime since Kubernetes has evolved and come on the scene. And these are some of the questions we've asked ourselves. So, what if you could import an existing cluster into Rancher and manage it all from a single pane of glass, a single viewpoint? So let's say you had something in GKE, Azure Container Service. These are managed Kubernetes installs. Let's say you had your existing on-prem Kubernetes. And a lot of times in a big enterprise, there's many organic croppings of Kubernetes over time. Different teams experiment and they create their own little implementations of it. And so sometimes you need to be able to combine these in a large organization. So we thought about that problem. And then we thought about what about customers who like or people who like our classic experience. Some of the things like we showed you of the GUI, being able to click on an app and deploy it, having a catalog, things like, Docker Compose. And we said, what if they could also have that experience and leverage Kubernetes power and have it be under the hood? So kind of, democratizing Kubernetes, right? Really just making it accessible for all. And then, of course, like I said, what if you could use Docker Compose with all of its simplicity and really straightforward behavior and have that produce pods, services, replica sets, deployments, all those really, really powerful concepts. So this is what we've been thinking about, and I'm excited to say we actually have an opportunity to give you a sneak peek tonight of some of our new technology that we're just about to release. I was just given permission to do that this afternoon, so really excited to show you this to you guys. Please don't make a big deal about it yet. It's going to be in the press soon, but you guys are getting a special sneak peek. I hope no one from Rancher finds out I'm doing this. No, just kidding. Oh, there's Sheng right there. That's not good. So Elena's going to show you guys the sneak peek. This is really cool. So
I'm very excited about. So let's close the old UI and now let's open a new one. Here we go. Welcome to Rancher, next version. And here you see two choices. You can either use your existing Kubernetes cluster that can be deployed on Google Container Engine or an Azure, or you can add hosts and Rancher will provide the embedded Kubernetes cluster for you. So I'm just going to choose the import option. So just the URL is not the local host, obviously. Right, now I go to the Google Container Engine. So here I have the GKE deployed. We're going to connect it first. So then I go back to Rancher UI and I copy this command and execute it. Right. So it creates all the all the Rancher system services. And then in some time, all the
Build's finished.
no, that's my debug mode turned on.
Oh, okay.
So I see all my GKE hosts in here, and I can start deploying containers. And I can actually, I want to show you how to manage the clusters. So this cluster is imported. You can add as many clusters as you want. Let's say I want to add embedded. Added one. My new cluster, and I can choose whether to use the existing Kubernetes cluster or the embedded. For that, I just need to add the host. Similar to what we showed earlier, just execute this command on any Linux box of yours. So now it is time to actually go and deploy the Kubernetes application in the new UI. So here we have the apps view, where you can launch the application from the Rancher Catalog. So this catalog consists of the templates of the Docker Compose format, as well as the Kubernetes YAML files, and we are adding the Helm support in the future. So you can deploy, you can actually take your Docker Compose file, and the application will get deployed on Kubernetes. So your containers will get translated to pods. Or if you're used to the Kubernetes format, you can, like for example, let me show you the dashboard. You can view the details. You can preview the YAML file that you're going to deploy. Here's the controller and the service. And the same with the Docker files. So you can see the Docker Compose files in here. And as I said, we're going to provide the Helm as well.
Yeah, so it's important to point out that we're not obfuscating or removing access to any of the Kubernetes APIs. You can still use those native options with all this, but we're giving you an additional ability to program Kubernetes, if you will, using things that are a lot more intuitive, like Docker Compose and the Docker constructs. So you're not losing any power, you're just getting extra ability through another avenue that some users in your organization might find much more appealing. Oh, yeah, you can add your own. So it's a Git-based catalog. It's just some folder structure and some YAML. So you just simply, usually in an organization, you have some PR, GitHub repo, and you make a PR for it. People can add their own stuff through PRs, and then you can crowdsource internally all the catalog items. Yeah, it's very popular.
Another option to deploy your application is just by going to Rancher UI and click on Add the Container, give it a name, give it a scaling option. You can either be a standalone container or a service of scale 1, or it can be a global service. It means that it gets deployed on every host in your system. And when I click Launch, it will actually get translated to the Kubernetes pod. You can create the balancers, you can create the DNS records, volumes. So it's just a user experience. And as an option, we also provide the Kubernetes dashboard. You can go to the Kubernetes dashboard and manage your app from there.
Cool. Well, thank you very much for all your time. And we want to make sure there's plenty of time for questions, anything we can answer about this. I know there's a lot of stuff covered, so anything you want to go over in particular? Sure.
Yeah, sure. So the etcd cluster, like I said, is highly reliable. We support the disaster recovery. We support the HA for it. The same for the API server. The downtime time is really, really small. Yeah, definitely. So all the health checks are configured, so it knows when the application goes down.
Like zone awareness is usually done by labels, so you provision with labels, and then you create selector rules that will have it, balance evenly. Yep.
And actually, yeah, and you can dedicate the specific host just for each CD and other set of hosts for the control plane.
All applications? So, like, what applications? So as far as the applications themselves, it's no different because they're still running Kubernetes. In Kubernetes, they're still pods. They're still experiencing all the same technology benefits. What's different is the user. So I would say the engineers benefit because they can do their work faster, get to market quicker, go home on Friday on time, right? I mean, that's the end goal. So the applications are still going to benefit from Kubernetes just as they would anywhere else. It's the same technology. Does that make sense? Or okay, cool. What are the failure points? Well, I mean, usually it's hardware failure at the end of the day. The software is Docker itself uses a lot of the Linux core technologies, namespaces, C groups, IP tables. It's not anything, the runtimes are all in Go. That's the only thing that they write, but they're really leveraging Linux core concepts that are very solid. Right, and so the health check should catch that.
In Kubernetes, it's actually, you can configure the parameters, like you can say, don't let this node to occupy more than this certain amount of CPU, and if that happens, just migrate all your containers to other hosts. So it's all configurable.
One scenario I will say that I see a lot is etcd failing. Slight hiccups in the network partitioning. If any of you guys have worked with distributed systems, you know how consensus can get really upset when there is a break in the network and it makes it a hard decision to partition. So that's something we provide a lot of tooling to help ease the pain of, because it's not fun. So yeah, etcd is definitely something you really got to keep an eye on, but we'll help you with that. Any other questions? Yeah.
Almost immediate, so we don't align with the Kubernetes releases, but as soon as the alpha version is released, we start testing it. So we test all the basic functionality, we test the installations and upgrades, and as soon as the Kubernetes goes out, maybe the very same week, we release our Kubernetes to our catalog, so it becomes available to the users. And it's all tested, it's not like you just blindly take it from the. We do support the rollbacks. BayLISA. So the etcd data is preserved, and then we don't remove the previous container with the previous Kubernetes version. We deploy a new one, and we make sure that the health check passes before moving on, meaning that the endpoint is available, and only after that we stop the container. And you can always have an option to roll back if things don't work, and the rollback it's almost immediate because the containers are not removed; they still exist. You just have to bring them back.
Oh, right. Yeah, sorry about that. So yeah, I was just saying storage and persistent volume claims are something that are definitely supported. Definitely a more advanced use case of Kubernetes, but supported. Did you have a question, sir? Nope. No other questions? Okay, so we have a quick giveaway, if you guys don't mind. Oh, one more question.
We have our own CNI plugin, which is IPsec and the VXLAN, but we are working on the VN plan, and we are planning to bring them aboard.
So they didn't let me get a t-shirt gun. That's really what I wanted. So we'll have to just kind of do this the old-fashioned way. So I have a few t-shirts here. So a couple quick questions, see who was paying attention. What was the technology that Kubernetes was based on at Google? Oh gosh, you all know it. Okay, I got to give it to him for 7, right? Because I think that was the more advanced answer. But large, does that work, or extra large? You can always just find us later too if you want. Okay. What is so the next question is, so with Helm, what is the server-side component that Helm works with? Anyone remember? Tiller, very good. Okay. And then what year did Google release Kubernetes? 2014. Yeah, very good. Okay. And then what is the next version of Rancher that we showed you today? Super secret 2.0. Yeah. Okay. Okay. And what is our networking topology? What does that provide you guys? Anyone remember? It's a replacement for Flannel or Weave, right, or Calico managed networking, right? Okay, no one got that one. And that's all the questions I have. So we have some more t-shirts. So come see me after. We have lots of blue cows too we want to get rid of. We've been asked to try to pass these around. They're really fun though. The kids love them, you know? They don't moo, no. So, but thank you so much. Any other questions before we wrap up? All right, thank you so much, guys.
Everybody, thanks for coming. Thank Rancher for a great talk. We actually have a raffle to give away too from ScyllaDB. We have 2 tickets to give away, so you had to be registered, RSVP to this, and you have to be here. And our super secure random number generator has picked a list of winners for us. And the first winner we have is Leora. Yay! You want a ticket to ScyllaDB? You want a ticket to ScyllaDB up in San Francisco, yeah. And then the next winner is excellent, excellent. Israel? And the next winner we have is Thomas Mason. Is he here? Hey! Okay, we moving right along. The next one would be Dalton Conley. Yay! So I have your names. Through the Meetup site, I will send you the code that you can use to get your ticket. That's all we have for this month. Thank you for coming. Thanks again to Rancher and to PayPal for hosting us, and hope to see you again next month. Oh. Thank you.